Hi everyone, thank you for dialing into the June showcase this afternoon. And after the celebratory showcase a few weeks ago, we're just going back today to our usual format of the progress updates from each project. And we will be kicking off with the Wildlife Watcher and our objectives. So for those that don't know or don't remember, we are building smart, flexible and affordable wildlife camera system that's designed to detect a wide range of species, and it aims to have a reliable motion sensor, high quality day and night imaging, long battery life and a mobile app to enable users to control the cameras remotely. And it will also feature an onboard AI for species identification and an easy way to train new machine learning models. And also real-time notifications sent via LoRaWAN when a species is detected. In terms of where we are right now, we have completed the MVP1 stage of the project, and which is the lizard detection, and we're currently in the process of wrapping up MVP2, which is the rodent use case. And as for the progress, the team has created a new streamlined design of the PCB, so printed circuit board, equipped with a motion sensor, power supply, flash, and connectors. A custom case for the board is also being printed and will be able to be tested soon. And we're also in the process of testing the motion detection, sensitivity, and its effectiveness in low light, which Dev will expand on shortly. And we're also training a new rodent model that we can upload and test the AI recognition with. And additionally, the team has set up the LoRaWAN and Trap NZ communication, which will let us send alerts to users' phone via SMS or email. And Tobin will briefly talk about that in a second as well. And finally, as for the documentation, we're creating a user guide that will be used to set up the camera and troubleshoot. And we're putting together a sequence of events and a communications diagram to map out how and where every data point is saved and sent to. So a lot of great hard work from the team, thank you. And now I'm passing on to Dev and Tobin for the demo part. And did you want me to keep sharing my screen, or did you want to share your own screen?
You can still share your screen if that's all right with you.
Yep, that's fine.
I will maybe slightly say next one, please. Okay, sweet. About the motion detection testing. So the goal for us is to really test different conditions regarding that testing. So I'd say that first of all, the PCB, the device that we are using connected to the camera, is working really well, thanks to Charles. The different behavior that we wanted to test the motion detection on was daylight, low light, pitch black, and no movement. So I'd say that during daylight, everything is working really well. If there is movement, the device is just recording whatever happening in front of the camera. During the low light and the pitch black, different scenarios, this is where the test that I did, you could see that on the middle image. So I just set up some testing regarding huge cardboards and object of interest, and just having something on the top of it just to manipulate how many light is coming into the different camera. So the goal for me was to see what could be the thresholds of a detection during low light or pitch black scenarios. So we have this number, which is 0.01 lux, which is the threshold of motion detection. So it's really low. So the goal for us was also to make sure that if it's fully pitch black, there is still some motion detection. So based on that value, we set up different profiles of sensitivity. The camera that we are using can be tweaked. So you have few different elements, few different variables that you can modify to create those two profiles. So we went for low and high sensitivity based on few variables that are, for example, light coefficient, region of interest, and latency. So you can see on the third image, the lower one, this is mostly like the list of elements that we can tweak. So it's quite huge. So for now, it's low and high, but maybe we could have different profiles regarding the fields that where we are putting the camera on. Like if it's a forest, we may want to have the device not recording like the movement of the leaves, for example. So that's about motion detection. Everything is working well, and we will continue tests regarding the really, really low light and pitch black environment to see if we could, thanks to the profile, have a better motion detection. Okay, we can just go on the next one. And we also create with the team an online user guide. So you have this QR code that you can scan with your device of choice. And you will have, or you can just copy paste or rewrite the URL that you can see here. This is still a work in progress, but the goal for us is to have a really easy to use and easy to maintain for the team website that will include all the user guides. So you can see on the image, the bottom image, this is the home page, and inside the home page, you have the list of user guides. So let's say that a user is coming in a specific in the website and want a specific user guide, they can just go to the page and they will have a downloadable version of it. So it's working pretty well on the device of choice that you will use. So everything is set up, and the goal for us is just to populate all of those user guides. For now, it's just like bare minimum, but it's good to have an online version that is so easy to maintain, especially for developers that are using Markdown files a lot. Yeah. I pass the hand to Tobin to talk about like NZ Tra datasets and notifications.
Yeah, cheers, Dev. Sure, so I'm just going to cover one of our communication methods, which is LoRaWAN. Essentially, on the Wildlife Watcher device, we have two methods to communicate wirelessly, and one is Bluetooth. So that'll be for setting up the device for deployment of the device and updating device settings, etc. And the other piece is an antenna that's attached to the device, which is our LoRaWAN antenna. And this is used for our real-time notifications to the user. So we essentially, you can see the workflow that's on the screen. The LoRaWAN, we send a payload message from the device, and that gets received by an IoT gateway. So the IoT gateway is essentially, it forwards messages on. So from a simple end device, it'll receive that message and then send it on via some sort of satellite network or bigger infrastructure. Now, the thing with this at the moment is we do rely on other infrastructure to exist already. So one good example is IoT Taranaki. They have setups already, so we're able to tap into them and set up our devices through them. It'll receive our payload messages and then forward it on via TrapNZ. Now, TrapNZ is an online platform used for New Zealand conservation and monitoring projects. Our end goal will end up having our own infrastructure for this, for notifications to users. But for now, we don't need to reinvent the wheel. We can tap into them and use their resources that already exist. And when you create a project from TrapNZ, we're able to forward it on via a webhook from one of those IoT gateways, and it will be essentially a receiver for our notifications. So we're going to be using that for any neural network positive detection. So if the target species is tracked and we do have some positive results, then we can send real-time notifications to the user via either the TrapNZ app or the website that they can receive, or we can use it for device statuses. So we can use it for heartbeats to know the device is still awake, alive, anything like that. So yeah, that's essentially it for the most part. We do have ideas down the track to extend and increase our coverage for very remote places such as mesh networking. But for now, this is a nice infrastructure that exists that we can tap into without having to create everything on our own shoulders. but also be able to get some real-time notifications to the users.
Great. Thank you, Tobin. And just quickly going through the next steps, we'll be wrapping up MVP2 to have a working camera for testing in the field. And we want to enable user to be able to choose higher quality pictures by selecting a Raspberry Pi camera and time-lapse functionality in addition to the motion sensor. We will add guidelines on training users' own models and setting up notifications to the user guide. And we'll continue the comprehensive testing. So testing of the device case, the motion detection testing, AI rat recognition, connectivity, and the LED setup. And finally, are there any questions for the team? Kalindi.
Hey, one question. I kind of asked it at some point already, but I think it's really interesting because for me it looks we have two MVPs. The first one is the lizard, and the second one is the mouse. And to me, the lizard feels much harder to do than the mouse. So why is the mouse or rodents MVP 2 and not 1? So that the order.
So for the lizard use case, the reason why it's simpler is because all we wanted to achieve there is actually taking pictures of a lizard when it moves in front of the camera. But for that, we actually just set up a time lapse to take pictures every so often. So we would set up a frequency that we want the pictures to be taken. Whereas for the rat use case, we don't only need motion sensor, but we also need the AI recognition model on camera to be able to recognize the rat, because the rat use case actually, because it's a predator control, it comes with real-time notifications as well when the rat is detected. So that's why the rat use case was a little bit more complex.
Okay, cool. So basically the lizard use case is actually like it takes the photos and then the analysis happen after, whereas
Yes.
for the rat use case is at the same time. Cool.
Yeah, the rat is recognized in real time. Thanks for the question, Kalindi. Anyone else? Nope. Let's move on to the Spyfish team. Did you want me to keep sharing, Kalindi?
Yeah, I think it's just the easiest.
Yeah.
So as mentioned before, the Spyfish Aotearoa objective is to basically utilize machine learning and citizen science to monitor marine reserves more efficiently. So to make things that already happen just a bit faster, better, or able to get more done in a shorter amount of time. So let's see what we've done over the last month. So if you go to the next slide. So here we can see the result of one of basically the first 3 lines, which is that we trained a draft model to identify snapper and bluecot, so only 2 species for now. And we use that model to annotate a few of the doc videos, pulling them directly from AWS. The reason why this is cool is because it basically is starting to create our pipeline. And also these videos are 10 gigabytes and half an hour long. And we can process them pretty quickly on the Nessie New Zealand high performance computer. So it's things are starting to come together. And this having this first results of the machine learning means that we can also compare the existing annotations from experts with what we are getting from the model. And also, I think I've had the last point, the more data cleaning and standardization on every single presentation so far, but it's an ongoing process. And I guess the exciting thing is that we're also starting to build automatic issue flagging. So if there's some issues with the data now, we will be able to like flag and inform the people who can clean, because I guess the interesting thing is that data keeps coming in, like new data keeps coming in, and then there might be issues in the way it's imported as well. If we go to the next slide, so the interesting thing about what we're up to is that we now have, especially with having set up the supercomputer and getting the machine learning model to do the annotations, we have almost all the puzzle pieces. And so our next step is just trying to connect them all and making sure, like building the pipeline from beginning to end. And if you go to the next slide, I guess I have a question for both the Spyfish team, but also for everybody, which is how do you balance basically building an MVP and just sending out a product to maybe the users to see how it's done, and how do you and the balance with having something that is production ready and one makes sure that everything works as it should be. So what do you think? Victor, do you want to start? I see a little smile.
Yeah. So yeah, there is value in having prototypes and MVPs, so that people can actually see what the product or what the solution looks like. But yeah, to make it into production and to maintain it is it takes a long process. So I've seen it throughout every single project that we have done. Is cool and fun to put things together, and it kind of looks like it's done, but in the moment that users start to use it, then you're like, oh, you know, how to maintain it, oh, we haven't really touched on this, and oh, what is the documentation and all these processes and stuff like that. So I think that there is value on speeding up that time to MVP or proof of concept. But yeah, mindful of the limitations of that. Passing it on to Tash, because I think that she's probably tested proof of concept and initial, you know, like we have switched so many platforms and different things, and it's just also an iterative process of having things out in the wild, but also working on our end. Tash, passing it on to you.
Yeah, thanks, Victor. I was going to touch on a bit on that in my presentation, but that's exactly right. You think you've done something and you think you've got it because it's lived in your own head for such a long time that you think it's obvious, I think might be the thing. So until it goes out into the wild, and then it's like, oh no, this is not good. Yeah. And then a lot of limitations are also not just around what you have done, but utilizing other people's tech in that. We've found that to be quite a bit of a challenge at times as well. But I like seeing my product being used because I like to have the feedback to see if we're on the right track. Yeah, if that answers your question or not, Kalindi, I'm not sure, but yeah, that's what I think. I think it's cool to see it being used, and it's cool to see people interacting with it and to get the feedback, because you don't know what's wrong with it until it's out there. Yeah, that's me.
Yeah, that's a good quote. You don't know what's wrong until it's out there. Cool. Does anyone from Wildlife Watcher want to weigh in?
I agree, and I think that when you obviously release a product, you can't predict every single scenario. So you basically give that to the users to test for you, which is the best way to test it, because all we can do is test the basic functionality that we know about, and then the users do the rest for us. And I think it's a great way to get feedback and even prioritize the next features, because what you think the next iteration should be might not be what the user thinks or what the user values most. So once you release your MVP, the user then tells you what your next steps are, which informs your MVP 2, beta, iteration 1, whatever the next stage is.
And I will add like maybe scalability of something, like a product. If we take a look at like mobile application or video games, it's every time the same pattern. They are just deploying the app or the video game inside a small team and then just growing the number of users that could just test the product and also give feedbacks. So version 0 is really like alpha, beta, and everything. It's very useful. And yeah, taking a look at video games and mobile app would be useful in that case.
Oh, thank you. Caroline, did you want to say something else?
No, I just wanted to pass them back to you. Is there anything else,
Ah.
Kalindi, that you wanted to share?
No, that's it. There's just do you have any questions, which is on the next, if you go to the next slide, I think. I did upload a new video, but I'm not sure. Yeah, there is. It's the new video. So there's just 2 sharks, so it's cute. Yeah, questions from Tobin.
You mentioned setting things up with Nessie and a high performance computer. What actually is that, and how does it integrate with your project?
So Nessie is I guess the New Zealand supercomputer, and they've been really great at helping us. They are very responsive to any support tickets and their office hours that I have been extensively participating at. So big shout out to them. And otherwise, it's just I guess there's a few supercomputers around the world that support science and other kinds of projects. And I think, and I think Victor can correct me. There's some sort of application processes, and so it's part of also the funding or the support. And we have 2 relationships at the moment. One is with Nessie, and one is with Lumi in Europe through our also Gothenburg University collaboration. And so basically it allows us to run the training and inference much quicker, because half an hour of video to run machine learning on that, like on my computer, it would take very long. But like, for example, it takes less than half an hour, and I think it's more because of the logs it prints than actually the how long it takes. So it's basically GPUs and ability to just do the training faster, training and inference, and getting the results. And because Doc, for example, in this case, has a lot of videos, that's a way in which we can process that. Victor, any add-ons?
No, you define it well. Supercomputers, these computers that are shared for mostly research purposes. Historically, it was mostly for climate and weather predictions, because it's quite computational intense. But nowadays, with machine learning, it has increased their use to different topics. And yeah, it's been great to be able to have their support.
Yep.
Perfect. Any more questions for Kalindi?
Yeah, can I ask what type of sharks those 2 were that popped up?
Sorry, say again?
I was just wondering what type of sharks they were on that video.
I think it's carpet sharks. But is it?
I think so.
Cool.
Yeah. They're
We don't have a marine
They're-
biologist in the room, but yeah.
Oh, they look cool. Thanks.
yeah. Yeah, it's cute. I'm starting to get to know a few of the friends underwater now. Little comment, I went to the store last time. Like where I come from, we don't have that kind of snapper, but I'm in New Zealand now. And then I went to the store and there was snapper in the store, and I almost cried because like, no, these are my friends. I see them on the video all the time. Anyways, that was sad. Yeah. On this note, Tash, you can take it on.
Oh, good on you, Lindy. I just want to say, man, you guys, your projects are phenomenal, and it makes me feel quite insignificant. Oh, I'm so proud of everyone. It's like what you've achieved is like exciting. Oh, it makes me really excited. Anyhow, what about AI? We've had a few speed bumps, a few along the last probably the last 3-4 months. So I'm still working. I've just finished uploading the program now. The third party that we were using to deliver the program wasn't able to handle the amount of traffic that we needed it to go through. Like, it was crashing with just 15 students trying to all log into the program at the same time, and it wasn't a very easy platform to use. So I have been uploading it and embedding it all into the Wildlife AI website, and or into the the demo website. Anyhow, so I finished the demo and the program this past week, so it's all done. Hopefully, until Victor looks at it and finds something else that needs fixing. So that's been a really big process, because we've had to upload it probably 3 different times, three different ways. So that's really pushed us behind in the timeline. I was hoping to have started promoting the program to schools by now. But that's okay, because now that we've actually feel like we've got a really good quality product to be able to promote, and it looks quite professional. So that's pretty much where we are in regards to the actual program. I've put a link on there, wildlife.ai/demo, but don't go to it just yet, because it's just waiting for Victor to upload it onto the website. But that will be the demo. So I don't know. What's your timeline, Victor? How long should we give you?
Soon.
Pardon me?
Soon.
Yeah, give us a week or so. Yeah, and then I'll be approaching schools. We're coming into school holidays for the next 2 weeks, so I'll be approaching schools in the new term, no doubt, trying to build some interest and get some people wanting to come on board in term 4, which will be good. Term 3 and 4, I am actually promoting teaching the program to a school, and they're paying for it, which is exciting. So one step closer. So that's where I am there, but I don't know. But like, part of the program is we created a lot of video content that was specific to the program. And so I thought I'd just share the first video. It's only 44 seconds long, but you get to listen to me a bit more. I thought I might just show you a little bit about what the program is about. So I don't know if you can get that to go, KK.
Yes.
Kia ora, I'm Tash, and I work for wildlife.ai, and I'm so excited. We're about to go on an incredible journey discovering how AI and conservation work together. We're going to be meeting some incredible experts who will be able to teach us lots of things around te taiao, conservation, and AI. I'm a teacher, and like you, I am passionate about New Zealand's environment and all the incredible creatures that live in it. I'm passionate about protecting our tonga, but I don't know much about AI. So would you like to come along with me while we find out some more? Let's go.
It's cheesy as, but there you go.
So good. I love this.
So all the videos really are just real short snippets, and I interview lots of different experts, and it's all sits alongside the program and the activities that we get the students to participate in. So yeah, that's it, done. So no, that's me. I'm all done. I don't know if you have any questions, but that's fine if you haven't.
Perfect. Thanks, Tash. What is the example of the experts that you've interviewed?
Oh yeah, so for instance, in the video there, where it's paused on, Tane, he works for Te Aotearoa, so he which is through Sustainable Taranaki, they go into schools and teach and support Māori students around how to reconnect with Te Taia, like the land or nature. Te Taia's nature, yeah, and just how to, like, some of the more traditional, I think, like ways of looking after it. They regenerate the bush by growing, like collecting and growing seeds. They do a lot of gardening around the moon. I can't remember what it's called now. Yeah, so it's just bringing in a bit more. Is that right, Victor? I can't think. Yeah, so I think that's probably about. It's really that cultural connection to the land and conservation for Māori people. Who else? Oh, Karen from Project Reef, which is a reef down in South Taranaki Bight, which is protected by, well, cared for by the community. So it's not part of any conservation areas, but it's an amazing reef. So they've kind of taken that under their wing, look after a bit. They're fighting the government at the moment around seabed mining in that area, so it's really important. Yeah, and then I've worked with Department of Conservation and Victor as well. I've interviewed Victor. So yeah, I've learned heaps, so it's been really great.
I saw you were on a boat. Oh, sorry. Sorry, you can go.
No, you go.
I saw you were on a boat. Were you dropping cameras or were you doing something else?
Yes. So Cam and Cam, Oscar, and Rebecca from Department of Conservation, they took me out, and yeah, it was so cool. We put out the BUV, the Beta Underwater Video cameras, and did a heap of recording around that, and just talked about the importance of. So in the background of that video, there is Tapawai Marine Reserve, and that's a marine reserve within New Plymouth, and so we just talked about the importance of marine reserves and conservation on the whole. Yeah, it was cool. Lots of amazing experiences. So I'm stoked to be able to have shared that with the wider school community soon, so it'll be good.
Yeah, thanks for sharing it with us. I was actually going to say that this view looks incredible.
Oh yes.
So I was going to ask
you would have seen that. Kalinda, you climbed Paratutu, did you? Yeah, so Paratutu Rock is just to the right of Tāne there. And that, yeah, it's a short walk, I don't know, 15, 20 minutes to the top. It's quite steep, but it's an amazing view. Yeah, so it's in Taranaki on a good day. Not now.
Amazing. Thanks, Tash. Are there any more questions for Tash?
I just want to say that this project is also really cool, and that you need to, when you start school, you just know what your parents are doing or what your parents' friends are doing, and there's it's good to learn about the things that one can do earlier on. There might be someone working on this in a few years because of this. So
thanks, Claudia. Fingers crossed. Yeah. I'm actually, side note, I'm going to Great Barrier Island teaching for 6 weeks in August, and I'm really excited to take the mahi that Wildlife AI have been doing over there as well, and talk to them and see how, spread the news, spread the word. Yeah.
Amazing. Perfect. Thank you. Thank you so much. Anything else from anyone before we end the showcase? No, I just want to say thank you to the presenters and thank you for all the teams for your hard work. It's so amazing to see the progress. Thanks for watching. If you're watching the recording, thank you for watching the recording, and see you at the next one. See ya. Bye.